Hey guys, welcome to today's lesson. Today we're looking at compound interest. You might remember from last lesson we looked at simple interest. Okay, so that's the basic type of interest that we use with the formula I equals PRN. Now, unless you hear the word compound or compounding, that's always going to be simple, but we want to look at what the difference is between simple and what compound is. So we used an example the other day of $1,000 being invested at 10% per annum for 3 years. And using our little I equals PRN, that's how we would calculate it out, right? Because what's happening each time, each year we're being charged on 10% of that $1,000, which means each year we're earning, in this case, $100, which gives us a total of $300. Now, in reality, that's not really fair. You might say, well, why is that not fair? Well, let's call it A1. We'll say at the end of the first year, right, you have $1,000, you earn 10% on that $1,000, which is that $100, which means at the end of that year, what you actually have, you have $1,100 in your bank account, right, at the end of the first year. The second year, you now have $1,100 in that bank account. So, should you not earn 10% on that $1,100? Because if I do that, well, what's 10% of $1,100? Well, that's going to be $110. Now can you see the difference? Because at the end of that second year, we're now going to have $1,210. The third year, of course, we're going to invest that 1210. We're going to find 10% of that amount, which is going to be $121. If I now add the 121 onto the 1210, we're going to end up coming up with $1,331. Okay, so let's now compare. With the simple interest version, at the end of our time, we're going to have $1,300 as opposed from the compound interest where we have $1,331. Now, look, I know what you're probably saying. It's $31. Is it really that big a deal? Well, when we're talking about $10,000, $100,000, yeah, it becomes a pretty big deal. So what compound interest does, compound interest calculates the interest at the end of each term. It adds it on and then finds the percentage on that new amount. In one respect, I guess it's kind of like building. All right, you build it after each period, whereas the simple interest works off this one or this first initial payment. So look, you could literally be doing this in 30 years' time, and with simple interest, after 30 years, you're still going to be earning $100. Whereas on this side of things, after 30 years, you're going to have a pretty big difference of amounts. And let's be honest, it's better being in our pockets than it is being in the bank's pockets or someone else's, of course. All right, so you can see the differing with each of those amounts, where it just keeps on getting bigger and bigger and bigger. Okay, so is there a quicker way? Because you might then look at that compound interest and think that's going to be a pretty complex sort of way of doing things. Is there a way to make that a little bit faster? And there absolutely is. So we have a formula just like simple interest. We have a formula for compound interest. Now the formula is slightly more challenging. Guys, you are given this in your examinations, which is a good thing. P brackets 1 plus R to the power of n. So like the last examples that we were looking at with a simple interest, these letters mean different things. So A means the final or the total amount. Okay, the final or the total amount. The P means the same thing as last time. It's the principal amount. I think it's PLE, should I say. Let's just change that, principal. We have R is the interest rate as a decimal. Okay, that percentage rate. I'll put here as a decimal. It's so much easier to use this as a decimal, guys. And N, now N is not the number of years. N is the number of compounding periods. Now that might seem a little bit strange to you, okay, but trust me, it will become clear in a moment. And I will say people do struggle with compounding interest, okay. So let's have a look at a question. Let's say, we'll do it in white, example 1. Let's say I invest $1,000 at 5, actually we'll do 5% per annum for 3 years, compounding annually. Okay. Now, I guess my first question to you will be, how do I know that this is compound interest? Well, reflect back to what I said to you originally. If you don't see a word that says compound or compounding, then it's going to be simple. But the minute I see that compounding word, I know that it's going to be A equals P brackets 1 plus R the power of n. So there are a couple of things to make sure here. We need to know what we're trying to find, what is the value, what is the letter that we're looking for. And then we need to plug the information in appropriately, but there will be some questions that kind of twin things around a little bit. So in this case, we want to find the total amount. So we'll say find the total amount, or the total value. So that means we're looking for A, which means the P we must have, and we know that the principal means the original amount, and that's $1,000. The R is the interest rate as a decimal, and the N is the number of compounding periods. Well, it's compounding annually, so that means once a year, and it's compounding it for 3 years, so which means the N equals 3. Now this is important because you'll see in the next question, I'm going to switch things around a little bit, but the most important thing for us to understand is that the percentage rate here needs to be in the same compounding period. Notice how this says annually and this is per annum, which means that the percentage is over an entire year, and the compounding period means that we're not going to calculate the interest until after 1 year. So they're both in the same kind of value. So for this question, we can simply plug this information in and say A equals 1,000 brackets 1 plus 0.05 to the power of 3. We can now grab our calculators and we can try to enter this information in as it seems left to right. Now if I do that, we should come up with, if I'm right, $1,157. It says 0.625, so I'm going to say 0.63. Now that's doing on my phone calculator, so hopefully that's all correct. Now, the other thing with this, they can either ask you to find the total amount, or they might ask you to find the interest. So if it said to find the interest, would you know how to do it? Well, hopefully you could say, well, hold on, I'm invested $1,000, which is my principal amount. Therefore, if I wanted to find the interest, we just take $1,000 away from our amount. If they ask that, I'm saying, which means our interest will be $157.63 if they ask that question. But in this case, they want a total amount, and we've got the total amount there. So you might then say, well, what's the hard question? What's the big thing? Because that's just using a formula. It's pretty straightforward. So let's have a quick. We had $157.63. So I know, again, it's not a huge difference, but look, we've invested the exact same amount of money at the exact same percentage rate. The only difference is we've compounded it monthly as opposed from annually. So the idea is the more often you compound something, the more money you get. Now, look, this has probably been a bit longer than I wanted. I hope this has been useful. If you're watching it today, have a crack at the questions, and then let me know if you have any problems. Again, A equals P brackets 1 plus R to the power of N. Be cautious of the rate and the N depending on the compounding periods. Okay. Apart from that, hopefully you'll start getting some questions right, and I'll see you shortly. Look at what a hard question would be, and we'll finish up on this one. So EG2 says I invest, we'll do $1,000 over a 3-year period. However, we're going to compound it not annually, we're going to compound this monthly. Find the total amount. So there is a slight difference. It's almost the same question, but this thing here is different. What does compound monthly actually mean? Well, that means that I'm going to calculate the interest being earned after each month, which means over a whole year, we're going to have this compounded 12 times. As opposed to when we were doing annually, it was only calculated once. So what is that going to mean for our interest? Well, hopefully, if we're calculating the interest more often, we're actually going to be getting more money over a longer period of time. So a couple of things here. We know that the A equals something or other. We don't know what it's going to be. That's what we're trying to find out. We still know that the principal is $1,000. We know that the N. Now, this is the tricky part. If I'm compounding it 12 times a year, and I'm doing this for 3 years, that means that I'm going to actually compound it 36 times. Okay, now that's opposed from just doing it over a whole year and compounding it for 3 years in total. That would just be 3. This case, we're doing it 12 times a year for 3 years, which comes up to 36 times. The R is also important because it's no longer going to be, I should have said 10% per annum there, I left that out. If it's 10% per annum, now that's what the interest is over an entire year, but what we want this is what it's going to be over 1 month, because we're calculating the interest after each month. We're doing it monthly. So what we're going to look at now is, instead of having 10% over 12, I'm going to put 0.1 divided by 12. Okay, so this is like the really important part, and this is why people really struggle with this stuff, because they don't divide the interest rate by 12. Now, that's not a particularly nice number. I'm going to leave it as 0.1 over 12. And now what I do is I come to this little formula of A equals P brackets 1 plus R to the power of N. So we're going to have A equals, we're going to have the principal of $1,000. We're going to have 1 plus 0.1 over 12 to the power of 36. Now, I know last question I did 5%, so this is kind of different. But what are the other challenges here that we've seen? So just to recall, that it's no longer to the power of 3, it's the power of 36, again, because we're compounding it 12 times a year for 3 years. Okay, and instead of having the 0.1, the 10% for over 1 year, we want it for 1 month, and we divide it by 12. Now, one thing that you're going to notice here, hopefully, that whatever you divide the rate by, in this case it's divided by 12, we have times the 3 by. Okay, and so that's significant. And now what we're going to do, it's a little bit more complex, of course, putting in our calculator, just a little bit. Now I want you to calculate that value. Now if you do that correctly, I'm hoping I did it correctly, I get $1,348.18. Okay, and when we get that amount, and of course it said the total amount, so that's my total amount. If they wanted the interest only, there'd be the interest only. Now, one thing I want you to do, because I probably should have used 5% for this question, right? Because I wanted to compare it with that previous one. So let's just have a quick look. If I did do this with 5%, right? So there's not much going to be different. Instead of being 0.1, it's 0.05 for 5% over 12 to the power of 36. Okay. If I recalculate that, I think that would be significant for us, because then we can compare it with that previous question to see what the interest is doing. So I'm just typing into my calculator now, and then what we hopefully get is $1,161.47. Now obviously that's going to be significantly less than the one we just found, because I'm using a 5% rate per annum instead of a 10% rate per annum. But the reason I did that is I want to have a look at that previous question, because here We have $161.47 by compounding it monthly. What do we have previously?